Well, greetings everybody. Here's a question I got today, and at least at this time that I'm making the video, it's question 9 from assignment 1.3. Okay? And the way that the question is given to us is that we're given a frequency distribution, meaning that I don't know what the raw data are. Like, I don't know what the numbers are that we started with. I just know that there were 29 cars analyzed for this, and for those 29 cars, there were 12 that have a gas mileage somewhere between 31 and 34 miles a gallon. And there are 11 that have a gas mileage somewhere between 35 and 38 miles per gallon. I don't know what those specific numbers were. I just have like this very rough information about it. Okay? All right. So that's what we have. That's how you understand what a frequency distribution is. That's what it tells you. And the question is, can you find the approximate mean for the frequency distribution? Now, before I show you how to do that, I want to compare real quick with another type of question. This is different than if I just had the raw data and I was going to find the mean. So just as a quick comparison, suppose you just have data. Suppose you just have some numbers that represent some kind of measurements, such as test scores, such as 29 cars, and the gas mileage of each car, something like that. That's just data. Those are just numbers that are given to you in a list, kind of like this. So I said, suppose you had data, suppose you had test scores. Okay, so say there's 5 test scores, and I want the mean test score, also known as the average. That's what most people would call the mean in everyday life. They would just say average. Then that's different. Okay, the way I would find the mean if I just had the data is different than how I would do it if I have a frequency distribution. The information that you start with and the information you're working with is different. Okay, so if I have raw data, just a list of numbers, and I want the mean, all you do is you add the data together and you divide by the number of data. Okay, so like if I want the mean test score, then I add the test scores together and I divide by the number of test scores. So in this case, I would say 86 plus 71 plus 97 plus 56 plus 82, and there's 5 test scores, divide by 5. That means, doing the math with a calculator, let's say the mean test score is 78.4. That's how we would do this with the raw data. It's not how we would do this if we have a frequency distribution. But it's easy for me to tell you how to do it. So here's how you would do this in the case of me having a frequency distribution and wanting the mean. Okay, how you do it? You add together. Now this symbol right here means I'm going to add together, all right, the midpoint of each class, because a frequency distribution is made of classes. Okay, the midpoint times the frequency of the class. I'm going to add all that together. I'll show you here in a minute what that's going to look like in this case. And I'm going to divide that by the total number of data. Okay, all right, so you can see that in order to do this, I need a number that's not on this table. Okay, I see that the classes are there and the frequencies, but not the midpoint. So I need to, I made my own table where I took the information in this one and I added a column for midpoint, because I need to know that for every single class. To calculate the midpoint of a class, take the minimum number in the class and add the maximum number in the class and divide by 2. So for this first class, here's the midpoint. Minimum number is 31, the lower number. Maximum number is 34, the higher number. Add those together, divide by 2. That will always give you the midpoint. That gives me 32.5. If I do that same thing for the next class, I'll get 36.5. Meaning if I take 35 plus 38 and divide that by 2, I'll get 36.5. So each of these midpoints I calculated this way. All right? Okay. Now that's all I think we need to know, right? It's the midpoint of each class times the frequency, add all that together, divide by the total number of data. So I'd take 32.5, the midpoint of the first class, times 12, the frequency of the first class, plus, I'm going to add it together, 36.5, the midpoint of the next class, times 11, the frequency of the next class, plus 40.5, the midpoint, times 1, the frequency, plus 44.5, the midpoint, times 5, the frequency. Okay, so that's that top part. That's how you understand that. How large is the data set? Okay, well, in the question they said there are 29 cars for which this table is based on. But if you take 12 plus 11 plus 1 plus 5, you'll also get 29. Okay, because when somebody made this, they counted 12 cars that had a gas mileage somewhere in that range, 11 in here, 1 in here, 5 in, that's 29 total. Okay, so I take all that, I divide by 29. If you want to confirm some of my calculations, make sure that you're getting it to work. That top number is going to be 1054.5 divided by 29, and it's 36.4 if I round it, as it says here, to 1 decimal place. So on your calculator, you won't get 36.4, you'll get like 36.36 something. It goes on from there. But it does say to round my final answer to 1 decimal place. So I'm going to take this number that I get my calculator, I'm going to round it to 1 decimal place. So that number that I'm getting, when I did this in my calculator, turns out to be 36.4 if rounded. Okay. All right, so that's how we do it. You might see both styles of questions on that assignment. You might see the question type where you just get the raw data, the numbers by themselves, and that's a pretty straightforward calculation. And you might get the frequency distribution. I would say that's, no more difficult, but it is different, and you'll have to be able to tell these two problem types apart.